Good morning. Department of Collegiate and Technical Education. Principles of Transportation Engineering. Module 1, Session 7. Highway Engineering of 5th semester. Civil Engineering. Subject code is 18CV56. Today, let us see what are all the engineering surveys to be done for highway alignment. So, whenever we want to fix an alignment for a highway, we need to do certain surveys. To start with, the first survey that we do is map study. Second one is reconnaissance survey. Third is preliminary survey. And the fourth is final location and detail survey. Let's see what are all the details that needs to be collected from the each survey. First one, the map study. The topographical maps are available from Survey of India. We need to collect that topographical map and we need to study the few parameters that are there on the topographical map so that we can avoid the valleys, ponds and also the lake. That means whenever we are taking the alignment, we should see that it should not cross a valley, pond or a lake. Why? For the simple reason, we need to construct the structures. If we want to take the alignment over the valley, pond or a lake, we need to construct some either the cross drainage work, that is the bridge, major bridge or a minor bridge. So in that case, the cost of construction of the highway will be more. So in order to avoid that, at the initial stage itself, we need to avoid valley, pond or lake. This can be done by studying the topography of the area where we want to take our alignment. Avoiding the bend of a river. So even the bend of a river needs to be avoided. If the road has to cross a row of hills, possibility of crossing through the mountain pass. Otherwise, you need to cut the mountain. Otherwise, you need to make a tunnel. The construction of a tunnel or cutting the mountain costs a huge cost. So, in order to avoid that, is there any possibility so that we can cross through the mountain pass? That possibility has to be studied. Map study gives a rough guidance of routes to be further surveyed in the field so that we can get the different alternatives or the different proposals or the different alignment so that we can select any one best possible alignment. Second one is reconnaissance survey to confirm the features indicated on the map. So sometimes what happens, all the features may not be possible to indicate on the map. So you need to personally visit the field, what actually is there on the site. So this can be done by what is known as a reconnaissance survey, because you know that on the map it is very difficult to show all the details. Only the key or the important features will be displayed on the map. So, to examine the general character of the area in the field for deciding the most feasible routes for detailed studies. So, there are number of alternatives available. You cannot take all the alternatives for the further studies. You need to select, assume that there are about 5 to 6 alternatives or the proposals or the alignments are there. You cannot take all the 5 or 6 alternative or the alignment for the future studies. In that, you need to select either one or two or maximum three for the further studies. So you need to filter that. So for that purpose, you need to do what is known as a reconnaissance survey. So once you visit the field, there itself you will come to know which one would be the most beneficial alignment or the route. A survey party may inspect along with the proposed alternative routes of the map in the field with very simple instrument like Abney level, tangent, clinometer, barometer, etc. to collect additional details. You can use any of the survey instrument to collect the details. Details to be collected from the alternative to routes during this are valley, ponds, lakes, marshy land, hill, permanent structure or any other obstructions that may come across. Value of gradient, length of gradient, radius of the curve, etc. These details has to be collected. Number of and also the type of cross drainage work. How many cross drainage work you need to construct? What is the type of a cross drainage work? Whether it is a bridge culvert, whether it is a CD culvert, whether it is a pipe culvert, like that. High flood level, right? How much is the high flood level whenever there is a rainfall, right? To how much level or to what level there will be a flooding. You can know that level by using any of the survey instrument. Soil characteristics is very important. What type of soil is there in the field? Whether it is a clay soil, silty soil, black atom soil, right? Geological features, any other geological features. Source of construction of material, stone quarries, water sources, etc. Because the availability of the material is very important, so that it should be available at the nearby place wherever you want to construct your highway or the alignment. Whatever the material that you use for the highway, it should be available at a nearby distance, so that the transportation cost you can reduce. So for that purpose, you need to identify the stone quarries. Not only the stone quarries, you need to identify the soil quarry also. Why? Because the construction of the highway or the road includes even the construction of the embankment. The construction of the embankment mainly depends upon the availability of the transported soil. So, if the transportation distance is more, obviously the cost of construction of the project will also be more. So, for that purpose, it is very important identify and also locate the stone quarry, soil quarry, water resources, etc. Prepare a report on merits and demerits of different alternative routes. So you just prepare. So you have number of alternatives, say about 2 or 3. You just list out what are the merits and demerits of each route or the alternate. So I'll be using the word alternate, proposal, alignment, almost all one and the same. As a result, a few alternate alignment may be chosen for further study based on the practical considerations observed on the site. Again, you need to filter. Out of these 2 or 3, you can select 1 or 2 final, right? So before arriving at the final proposal or the alignment. So for that, what we are doing is preliminary survey. So what are the objectives of preliminary survey? To survey the various alternative alignment proposed for reconnaissance and to collect the necessary physical information and details of topography, drainage and soil. So you'll be studying in detail, you'll be collecting the data in detail of each of these things. That is topography, drainage. So another important thing, because the drainage affects the your durability of your pavement or the road construction. So the drainage should be good. So what are the obstacles in drainage? How you can improve, or what are the preventive measures that you need to take? All these things you need to study. And also soil. Already I have explained. So type of soil. You compare the different proposals in the view of requirement of good alignment. You have, say, example proposal A, proposal B, and proposal C. So you just compare the different proposals, which is the best one. What are the advantages of each proposals? What are the disadvantages? What are the cost? How much would be the cost difference? Each and everything has to be calculated. To estimate the quantity of earthwork materials and other construction aspects and to work out the cost of alternate proposals. So as I told you, earthwork is a major component in the road construction. Embankment, cutting and filling quantity will come in the construction. So you need to estimate the quantity of earthwork material, how much it would be, right? How much is the cutting quantity, how much will be the filling quantity. Method of preliminary survey. So conventional survey instrument you can use, required for field equipment, taking the measurement. You just go to the field, take the measurement, dumpy level, theodolite, staff, arranging rod, right? Or collecting topographical and other data for carrying out the soil survey. So you can use the conventional approach for the survey. So just to name the things, what are all the details you need to collect and at what interval. If you are doing the survey on a plain terrain, both the longitudinal section and the cross section of the your proposed alignment, you should take at every 100 to 200 meter interval. On a rolling terrain, because you may see the more changes in the terrain. So for that purpose, you need to take at a closer interval, say 50 meter. In the hilly terrain, still the variations will be more. So you need to take the levels at every 30 meter. Other studies: drainage, hydrological survey, soil survey, traffic and material survey. So you need to do the traffic survey also. How much is the traffic flow? How much is the your two-wheeler, four-wheeler, truck, bus, etc. Everything you need to do. Not only that, even the at time interval from morning to evening or 24 hours. We call it as a 24 hours traffic data. 24 hours into 3 days. We usually collect the data for 3 days. So how much is the traffic? Material survey. So material survey, what are the different types of material that are available at what distance? How much is the quantity available? Is that quantity is sufficient for your road construction? All those things you need to calculate. So apart from that, you can use the rapid or modern approach also. Aerial survey, taking the required aerial photographs by obtaining the necessary topographic and other maps, including the details of soil and the whatever the details that you obtain. So you can use the modern rapid approach, that is by using the aerial photography. Finally, you need to, once you do all these survey, right, reconnaissance survey, map study, preliminary survey, final location and detailed survey. So that alignment, once you started from 5 to 6 alignment, then you come down to 2 or 3. Even you 2 and 3 you cannot carry out. At the end, you need to finalize only one alignment. There could be only one alignment between the two places. Assume that there is a place A and place B. You can connect that place, or you are constructing a road only one, right, by using the only one alignment. So fine, you need to finalize any one single alignment out of the available alternative alignment. So that is the final location. The alignment finalized at the design office after the preliminary survey is to be first located in the field by establishing the center line. So you will be doing all these things in the office, right? So once you collect all these details from the field, then you go to the office, design office, then you will be working out all the alternatives and you will find out which is the best alignment. Once you find out that best alignment in the office, the same needs to be transferred to the field. Okay, so actual field you need to transfer. How to transfer that alignment? By locating the center line of the your proposed alignment. So for that, what you have to do? Location survey, transferring the alignment on the ground. So whatever you have designed in the office, right, whatever which is there on the your sheet or on the drawing, it has to be actually transferred to the ground. This is done by transit theolite. Major and minor control points are established on the ground and the center pegs are driven, checking the geometry design standards. Okay, you need to establish some of the minor control points because for future checking, right, if there are any mistakes happens, right, you need to cross verify. Again, you cannot go back to the from the initial zero Chinese and you can start checking that. So that again takes a tedious process and it becomes very difficult. So for that purpose, in order to check the levels, you will be fixing some TBM, temporary benchmarks, so on and so forth. So minor control points has to be fixed. Centerline stacks are driven into the suitable intervals, say 50-meter interval, plain and terrain 20-meter interval, and in an hilly terrain. Okay, so suitable centerline has to be marked by driving a suitable pegs, say at 50-meter interval in the plain and also in the 30-meter interval and also the 20-meter interval in the plain rolling as well as in the hilly terrain. Next, once you do that, you are going for the detailed survey. Temporary benchmarks are fixed at every 250-meter interval, and all the drainage and underpass structures, even in the underpass and also the drainage structure means your cross drainage. It may be a CD, bridge, culvert, etc. Earthwork calculations and the drainage details are to be carried out from the level books. Cross-sectional levels are taken at an interval of 50 to 100 meter in plain terrain, 50 to 75 meter in rolling terrain, 50 meter in built-up area, and 20 meter in hilly area. Detailed soil survey is to be carried out. This is very, very important because the cost of construction of your highway mainly depends upon the traffic as well as on the soil, type of soil. The thickness of the pavement mainly depends on the type of soil. So for that purpose, you need to do the soil survey exactly, accurately. CBR value of the soil along with the alignment may be determined for the design of pavement. Okay, so the California bearing ratio is the one which will going to decide about your thickness of pavement. So this has to be found out. Anyway, you will be not doing the CBR sample in the field. You will be collecting the soil sample from the field and you are doing it in the laboratory. The data during detailed survey should be elaborate and complete for preparing the detailed plan, design and estimate of the project. So once you do all these things, all the survey and you have located the point on the ground, you need to draw some of the drawings and also you need to submit the entire thing in the form of a report. So that is nothing but report. So that report consists of the many parameters along with the drawings. So let's see what are all the key things that you need to present in the form of a drawing as well as in the form of a report. First one, key map indicating the location of your highway or the alignment, how it goes, what is the terrain, etc. Index map, you need to you need to show the different features like telephone, permanent structure, if there is any temple is there, right? So all these features has to be indexed. Then preliminary survey plan, detailed plan and longitudinal section. So longitudinal section according to the interval, right? You need to show at, if you are doing it for a 1 kilometer, so at every 0 chainage, 250 chainage, 100 chainage, 300, 350, 400, like that. Depending on the interval, you need to select, show the longitudinal section. Detailed cross section, similarly cross section also will be shown. Land acquisition plan, sometimes what happens, your alignment does not go in the government land, you need, it goes in the private land, that is the land belongs to the private property, so you cannot construct the road in the private property, you need to acquire the land. So even that land acquisition plan, how much is the extent, who are the owners, right? All these details has to be included, how much would be the cost, everything has to be shown. Drawings of cross drainage and other retaining structure, drawings of bridge, culvert, CD structure has to be shown. Drawings of road intersections, so if there are any road intersection junctions, right, median and also the rotary, right, it comes, you need to show that. Land plans for showing the quarries, even the material we get it from the quarry, whatever the soil quarry or the aggregate quarry, right, we need to show the location, how much is the distance, how much is the traveling time, all those things you need to show. So those are the drawings and also the report that you need to be done for a project, highway project. Coming for a new highway project, so same thing, map study, reconnaissance, preliminary survey, location and final alignment, detailed survey, material survey, geometric and structural design, earthwork calculation, even how much is a cutting as well as the filling quantity, payment construction, right? So what type of payment, whether you are constructing a flexible payment, whether you are constructing a rigid payment, right? What is the thickness, what are the different layers like subgrade, subbase, base, structural layers, everything, thickness, what are the different types of materials that you use, what is the design mix, everything you need to mention. Construction control, so what are the construction quality control, you can say that quality control needs to be done, everything has to be shown for a new highway project. So map study, reconnaissance, preliminary, location of final alignment, detailed survey, material survey, geometric and structural design, earthwork, pavement construction and construction controls. So another important thing is realignment of a project or a highway. That is, whatever the alignment we have seen, these were built very long ago. We can say that they belong to pre-automobile era, probably 30 years back or 40 years back. At that time, whatever the present day traffic we see today, it may not be there, right? Whatever the different types of categories of vehicles or the uh, load carrying vehicles are there, we cannot see, or not, it may not be there during that time. So now the traffic has increased, the demand has increased, the different categories of vehicles has increased, the load carrying capacity of that vehicle has increased. So all these things, in order to accommodate that, so whatever the existing alignment or road is there, we need to modify. There may be some deficiencies or difficulties may be there in the existing alignment, so we need to rectify that. So that rectification we can do it by a process called realignment. So what are the reasons that could be there for the realignment? So I think in the next slides I'm going to explain that. So there are about 6 to 7 situations under which we go for realignment of a highway project. Coming to this, right, realignment, as these roads were meant for a slow traffic, right? So whatever this alignment were there, they were very much suitable for the slow traffic, but the present day traffic, it is very difficult. So for that purpose, you need to do the realignment. The defects may be there, right? The defects may be there in the both the national highway and the state highway with respect to the geometry design, with respect to the design speed, with respect to the stopping side distances, with respect to the curves, with respect to the horizontal curve, with respect to the vertical curve, with respect to the ruling, as well as the minimum design speed, etc. All these things you can rectify in the realignment project. So what are the reasons, and also in what way one can improve the existing alignment? So first one, improvement of the horizontal alignment. Design elements such as the radius of the curve you can improve. Super elevation, if there is any deficiency in the super elevation, you can rectify that. Transition curve, provide a transition curve. Adequate side clearance, right? Inner side of the curve, shifting the curve to provide adequate side distance. Elimination of the reverse curve and undesirable zigzags. If any of these things are there in the existing alignment, definitely you can rectify in the realignment project. Improvement of vertical design elements like steep gradient, changes in the summit curve, increase in the side distances, correlation of undesirable undulations like humps, dips, etc. Right? If there is a more hump, more dips, right, you can rectify. Raising the level of the portion of the road when it is subjected to flooding or submergence or waterlogging during the monsoons. Only this some stretch of a road may be subjected to flooding, submergence, and also the waterlogging. That too only during monsoons. So you can just raise the level so that even in the monsoon you don't feel this type of a problem. So this can be done. That is by raising the level of the ground. Reconstruction of the weak and narrow bridges and culverts, changes in the waterway at the location slightly away from the existing sites. So these bridges and also the culverts would have been constructed about 20 years or 30 years back or 50 years back. Or even if you consider some of the roads in India, these bridges were constructed in before independence. Nowadays, it has become weak. You cannot travel on those roads. So even you can tackle such type of a bridges and also the culverts. Construction of overbridges or underbridges at suitable locations across a railway line in place of level crossing or across another road to provide a grade separated intersection. I think in many places in India, the roadway joins with a railway. So always there will be a problem. Whenever the train goes, you need to stop the vehicle on the highway for about 10 minutes, 15 minutes again. And also not only that, it does not happen only one time. There could be 20 or 30 trains running in that line, then you need to stop the traffic on the highway for 20 to 30 times in a day. So it's a disadvantage, and also it's not recommended, right? So for that purpose, you can construct depending on the site location and depending on the suitability, cost available, funds available. You can construct either a overbridge or a underbridge. Then, realignment required due to portion of the land being submerged under a water at the reservoir area on account of construction of a new dam. So, all these roads were constructed during the uh, pre-British era, right? So, there could be a after that, after independence, there could have been a construction of a new dam. So, because of that new dam, there could be a submergence. So, the entire area could have been submerged. So, even all these problems you can tackle in the realignment. Construction of the bypass to avoid the road running through the town or a city. Okay, So this is also just to give an uninterrupted traffic flow. Instead of going through the city or a town, you can construct the bypass. And the last one could be the defense requirement. Okay, so this is the reason, right, why you are doing the realignment and what are all the things that you are going to tackle in the realignment. Let's see some of the multiple choice questions based on the our today's study. The survey in which the details are covered roughly but not accurately is called reconnaissance survey, rough survey, map study, detail study. So in the reconnaissance survey, right, we'll going to roughly study what are all the features, what are all the structures, right, which is not there in the map study, that we're going to study in the site. So the answer is A, that is reconnaissance. The soil survey is conducted in which of the following survey? Preliminary survey, reconnaissance, map, and topography. So the answer is preliminary survey. We collect the soil sample. We study the what type of soil is there, whether it is suitable or not. What are the measures to be taken? So the answer is preliminary survey A. A closed loop used for the survey purpose is called open traverse, closed traverse, primary traverse, secondary traverse. I think you are aware of that in the survey. That is the closed traverse. What is the first step in the preliminary survey? Map study, preliminary traverse, detailed survey, detailed project report. So the primary traverse is the first step in the preliminary survey. So the answer is B. A KMF size should not exceed 20 by 22 centimeter, 32 by 20 centimeter, 32 by 32, 20 by 32. The answer is A. It is a standard size 20 by 22 centimeter. The index map shows dash, soil, topography, area of the site, plan. So the index map shows the topography, right? Topography of the area. So the answer is B. The approximate cost of construction evaluated for the project is called project report, project feasibility, estimate, detailed project report. The answer is C, that is estimate. We usually estimate what would be the approximate cost of construction. The report that includes all the works including the soil, bridges, topography, material study and drainage study is called as feasibility report, detailed project report, survey report, primary report. So this is called the detailed project report, that is the DPR. So the answer is B. The planning, design and construction of either a network or a new roads or road link is called highway project, highway estimate, highway interlinking, highway design. The answer is highway project A. Detailed size of drawings are prepared in which sheet? A1, A2, A3, A4. The answer is B, that is A2. Thank you.